Use Simpson's rule with 11 ordinates to find an approximation to the area bounded by y equals x e to the negative x squared, the x-axis, and x equals 1. So 11 ordinates, that means 10 intervals. And that's really important. There's 3 marks here. And so your h, well, the width is going to be 1 divided by 10, so that's 0.1. So that's enough if we just put the answer down now to trip that. So what we're going to be doing is going to the e-activity for this, which numerical integration, we've got it just here. And what I need to do is change that from the example we did in class last week to this new one. I do believe when you do this one, you've got to be just a little bit careful how you put it in. So I've got x multiplied by e, and it's negative x squared. And I'm going to put that in a bracket just to make sure everything is nice and tidy. And okay, and then we're going 0 to 1 with 10 intervals. I've already got 10 intervals in there, so that's all good, and that should just scroll itself down to the bottom now. And so what have we got? So there's midpoints. And trapezium rule gives us that. We're after Simpsons. Simpsons gives us 1. I'm not actually convinced by that. There might be something not quite right here. Let's go ahead and do this. The exact value of this. Well, 3 marks, so I've actually got to do the integral. So negative 2x e to the minus x squared dx, 0 to 1, and I need to multiply by negative 1/2 because that balances up the x. So it's negative 1/2 e to the negative x squared from 0 to 1. So it's negative 1/2. And if we put 1 in there, we get e to the negative 1. Put 0 in there, we get 1. So that's going to give me 1/2, 1 take away 1 over e. And there's no way that that's 1. So there's something gone wrong with this up here. So maybe I need to make sure I've used the right type of x. X e to the negative x squared. Okay, we've got all that. 0, 1, 10. Let's just give it another go. That's better. It seems to have worked now. So my Simpsons is 0.0. They want 4 significant figures. 0.3161. And the exact value is that, and we want the percentage error, and we can see looking across this that it looks like the Simpsons is actually slightly bigger, so we're going to use 0.316 0.657,194. Take away 1/2 of 1 take 1 over e. Of course, we need to divide that by the actual exact value, and then times by 100 to give us a percent. So I'm going to copy that, and I'm going to go to main, and I'm going to get a fraction template, and then I'm going to paste that. And I'm going to take away 0.5, 1 take away 1 over e to the 1. Let's close the bracket on that. Just want that bit, and we'll copy that down to the bottom, and then we'll multiply by 100. See what that gives us. So it gives us 0.0017%.